Alright, what's going on, people? Mr. Brunsvold here. Today's lesson is going to be on ionic bonding. So what is ionic bonding? Ionic bonding is when a metal atom donates electrons to a nonmetal atom and they form an ionic bond. So your metal atom is always going to be donating electrons to a nonmetal atom, which accepts those electrons. And then those two atoms, the metal and the nonmetal atom, will form an ionic bond. Okay, so recall from our previous lesson that metals lose electrons and have a positive charge. Okay, and so then what I want you to do on your periodic table is circle these elements in blue. Right, so lithium, sodium, potassium, rubidium, cesium, and francium, because these metals always form an ion with the same charge. And we'll talk about why in just a second here. So let's take the first item in that list here. First one is lithium. Now you do not have to write this down, so just watch for this portion. So the lithium atom, we see it's a lithium 7 atom, so we can see it's got the protons and neutrons in the nucleus here, and then since it has 1, 2, 3 protons, it has 1, 2, 3 electrons. Now what's going to happen is this atom is going to lose an electron, right? This electron right here, it's going to lose it. That's because this atom would be much more stable if it had an empty orbital, right? So it's going to lose that atom, or that electron, so that the second orbital is empty. And so then we'll end up with the lithium 7 ion. So it's the same amount of protons and neutrons in the nucleus, but we've just lost one electron from the second orbital. Because we lost one electron, this will have a positive 1 charge, and that's because electrons have a negative charge, so if you lose one, you'll have a positive charge. We can also think of it in terms of number of protons and electrons. So 1, 2, 3 protons, minus 1, 2 electrons. 3 minus 2 is positive 1. Okay, so that's the first atom, or the first element in the row was lithium. The second element in the row was sodium. And you can see it's very similar in structure because it has 1 electron in this outermost orbital. So we've got the protons and neutrons in the nucleus, and there should be 11 protons in this picture, which means that there are 11 electrons in this picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? But again, the sodium atom is going to lose 1 electron, so we're going to get rid of that electron. We're going to end up with an empty outer orbital. Right? This outermost orbital doesn't have any electrons in it, and so for that reason it also has a +1 charge. Now, we could show this for every single atom in that first row here. We just showed it for lithium and sodium, but we could show it for potassium and rubidium and cesium and francium. The pictures would be a lot bigger and it would be a lot more tedious to draw out. But what's important to note is that all of these atoms will lose 1 electron and form a +1 ion. So that's what I want you to write at the bottom of the periodic table here is +1. Okay, so now let's take a look at the atoms in this second row. So we've got beryllium, magnesium, calcium, strontium, barium, and radium. Okay, so we'll start with beryllium. And so beryllium, we can see, has 4 protons in the nucleus, and so it has 1, 2, 3, 4 electrons. Again, it's going to be losing 2 electrons, right? 1 here and 1 here. And that way it will have an empty outer orbital. So it'll lose those 2 electrons, become the beryllium 9 ion with this outer orbital being empty. And since it lost 2 electrons, right, remember in the last one it lost 1 electron and had a +1 charge. This one lost 2 electrons and will have a +2 charge. Okay, so then the next one in the row is magnesium. And again, we can see if we look at this outermost orbital, it has 1, 2 electrons in it. Again, we're going to lose those 2 electrons, 1, 2, and end up with an empty outer orbital. Since it lost 2 electrons, this atom also has a +2 charge. So, all of the elements in this second row here all have a +2 charge. Okay, now we're going to skip over the elements in this middle part and in this bottom part down here. Those ones are kind of complicated. Basically, a lot of those elements can have more than one charge, and it's kind of difficult for me to explain why at this point, so we're just going to ignore them at this point in your education, and we're going to jump to aluminum. Okay, so you can draw a blue box around aluminum, and then remember that since aluminum is the first, second, third element in its row, that means it has 1, 2, 3 valence electrons. So 3 electrons in that outermost orbital. It's going to lose all 3 of those electrons and form the aluminum 27 ion. Okay, so the ion should look very, very similar to the atom, the difference being it's missing those 3 electrons in the outermost orbital. Since it lost 3 electrons, it will have a +3 charge. All right, so you can go ahead and put a +3 next to aluminum. Okay, so that's it for the metals that you're going to need to know the charges of. Next, we're going to start looking at nonmetals. Right? And so remember that metals lost electrons and have a positive charge, and so nonmetals are just going to be the opposite. They're going to gain electrons and have a negative charge. Right? So nonmetals gain electrons and have a negative charge. So let's go ahead and circle our first row of nonmetals that you're going to need to know. And it's going to be these 4 right here. Those are called halogens. And those elements are fluorine, chlorine, bromine, and iodine. Okay, so let's take a look at what those atoms look like. We'll start with fluorine. So fluorine, we can see it has 1, 2, 3, 4, 5, 6, 7, 8, 9 protons in the center, and that means it's going to have 9 electrons around the outside. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now remember that nonmetals, they gain electrons. So this one is going to gain 1 electron. So I drew a little circle here just to show the electron that's gained. Again, you do not have to write this down, so just be paying attention right now. And so then it's going to gain an electron right there. So we can draw the ion with 1 extra electron in there. And so this atom, because it has 9 protons in the middle, but it has 10 electrons on the outside, 9 minus 10 is -1. So this atom has a -1 charge. Okay, similarly, we can take a look at chlorine. All right, if we look on the outside in its valence orbital, its outermost orbital, it has 1, 2, 3, 4, 5, 6, 7 valence electrons, just like fluorine did. 1, 2, 3, 4, 5, 6, 7. And so it's again going to gain 1 electron. So I just drew a little circle there to show where it's going to gain that electron. So now I've drawn it over here with that extra electron in the orbital. And again, since it gained 1 electron, when you gain electrons, you will have a negative charge. So it gained 1, so now it has a -1 charge. Right, so fluorine and chlorine both had a -1 charge. If we drew out bromine and iodine, they would also both have -1 charges. So all the elements in this 7th row right here all form ions with a -1 charge. So hopefully you're starting to see a pattern now. This went 1, 2, 3. This started with -1 here. So up next we're going to be taking a look at this row right here. So that's oxygen, sulfur, and selenium. Okay, so if we take a look at oxygen, it has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and 6 of those, 1, 2, 3, 4, 5, 6, are valence electrons. Right, it wants to get up to 8 in that orbital, so it's going to gain 2 electrons, 1, 2. That's where they're going to go. And so then we can redraw the ion, 1, 2, 3, 4, 5, 6, 7, 8. And again, it's going to have a -2 charge because it gained 2 electrons, so -2. It's because it's got 2 more electrons and it has protons. Okay, so then we'll take a look at sulfur. Same thing here. If we look at the valence, it has 1, 2, 3, 4, 5, 6 electrons. It's going to gain 2 electrons, 1, 2. Because it gained 2 electrons, when we redraw the atom as an ion, this ion has a -2 charge because it has 2 more electrons than protons. Okay, so then above this row right here, you can put a -2 charge. So hopefully you're starting to see the pattern at this point. This row went +1, +2, +3. These rows went -1, -2. So you can probably guess what this row is going to be, but let's just take a look real quick. So we've got our nitrogen atom. It has 7 total electrons over in here. And for valence, it has 1, 2, 3, 4, 5 electrons. We want to get up to 8. So how many electrons will we need to gain to get up to 8? Well, 5 plus 3 equals 8, so it's going to gain 3 electrons. So 1, 2, 3. And we'll redraw the ion over here. 1, 2, 3, 4, 5, 6, 7, 8. Because it gained 3 electrons, it will have a -3 charge. And then it'll be the same thing for the phosphorus atom. So I'll go through that real quick. 1, 2, 3, 4, 5 valence electrons, so it's going to gain 3. So it gains 1 here, here, and here. Because it gained those 3 electrons, now it has a -3 charge. So for our last row, we can put a -3 over the top. So make sure you've circled or you've put boxes around those 6 sets of elements. Those are the ions that you're going to need to know. Okay, so how can we use this periodic table to help us? Well, now that we have this built, we can use this to identify the ions that will be formed by different atoms. So, for example, if I start with sodium right here, and then take a look at the periodic table, sodium is right here. It's in the column for +1 ions. So then I will write it with a +1 charge. Now remember, we don't write the number if it's a 1. We just write the positive. So Na plus. So it'll be very similar with our next example, chlorine. Chlorine is right here. It's in that first column where everything has a -1 charge. So then I'll write chlorine with a minus. And again, we don't write the 1. If it's a 2 or a 3, we'll write the number, but if it's a 1, we just leave it alone. It's sort of like when you're doing algebra, and if the equation was y equals x plus 2, right? You wouldn't say y equals 1x plus 2. That's not how they write it in the textbook. It's just implied if you don't write the number that it's a 1. So same thing here. This is really a sodium ion with a +1 charge and a chlorine ion with a -1 charge, but we don't write the 1s. In the next example, we will write the number for magnesium because magnesium is right here. It's in the column for +2 ions. And so then when we write it over here, we'll write it as Mg2+. And remember that for whatever reason, we do the number in front of the sign. So 2+. If you do it the other way around, I won't mark you down. But the standard convention is to write the number before the sign. Okay, so next let's do nitrogen. Nitrogen is right here. It's in the -3 column. So we will give it a 3- charge. All right. Okay, next up is selenium. Selenium's right here. It's in the -2 column, so we're going to give it a 2- charge. Next up is potassium. Potassium is right here. It's in the +1 column, so we're going to give it a positive charge. Remember, we don't write the 1. Next up is barium. Barium is right here. It's in the +2 column, so we're going to give it a 2+ charge, just like magnesium. And then last up is bromine. Bromine is right here. It's in that -1 column, so we're going to give it a 1- charge. Why didn't that show up right? Well, this was supposed to be over here, so Br- is supposed to get written over here, folks. Not sure why that's not showing up right. Okay, go ahead and work through some examples then, or work through some problems. You can use that periodic table that you built. If you're looking for any of these periodic tables that we've built so far, because we've done a few of them now, if you want to go here to the course and take a look at resources and then periodic tables, I've got all of our periodic tables together. So here, let's just take a look at what some of those look like. We've got our dynamic periodic table here. This one's really good. It's a website. You can do a lot of really cool stuff in this one. A lot of neat features. You can click around on some of them, see what some of them do. Okay, next is nonmetals versus metals on the periodic table. This is one that we made a couple lessons ago. And if you look here, it shows where the nonmetals are and where the metals are. Okay, let's keep going. This one's just a blank periodic table, right? Nothing written on it. But if you're just looking for a regular periodic table with nothing marked up on it. All right, and then last up is the one that we just made today. Periodic table with charges. So you can see we've got the +1, +2, +3, -3, -2, and -1 columns. And then it's circled. Remember, the blue are metals and the red ones are nonmetals. Those are all the ions that you'll need to know for this course. And so you can use that on any of your assignments or quizzes. Okay, let me know if you have any questions. I'm here to help. Thanks.